So let's move on to percent composition and empirical and molecular formulas. So percent composition is just a way of describing the relative mass of each element in a compound. So let's take a look at mercury sulfide. So if we take a look at the percent of mercury, we just divide the mass of mercury, which we can get off the periodic table, divided by the mass of mercury sulfide, which we can also get from the periodic table. It's 200.6 grams per mole divided by 228.68 grams per mole times 100% gives us 87.7%. The remainder of the compound is just sulfur, so to get the percent sulfur composition, we just do 100% minus 87.7%, giving us 12.3%. Molecular formula. The molecular formula is the actual number of atoms in a compound. So for example, benzene, C6H6, has 6 carbon atoms attached to 6 hydrogen atoms. Hydrogen peroxide is the same, but with 2 hydrogen atoms and 2 oxygen atoms in every molecule. And C2H2 is the same with 2 carbon atoms and 2 hydrogen atoms. The empirical formula, though, it's the molecular formula above, written in the lowest ratio possible. So for example, we can divide both 6's over here by 6 to get C6H6 divided by 6 as CH. This is the empirical formula for benzene. Hydrogen peroxide would have an empirical formula of HO by dividing both of these by 2. And C2H2 will have an empirical formula of CH. So you'll see a problem because C2H2 has the same empirical formula as C6H6. But we'll get to that in a second. So let's talk about how to determine the empirical formula. So over here I have an example. We have a compound that we know to be 85.6% carbon and 14.4% hydrogen. We need to determine its empirical formula. So if we set it up like this, with carbon and hydrogen over here, let's assume we have 100 grams of sample. So if we have 100 grams of sample and 85.6% of it is carbon, then we must have 85.6 grams of carbon, and similarly 14.4 grams of hydrogen. Next we need to figure out the number of moles of carbon and hydrogen. So remember, figuring out the number of moles is just the mass divided by the molar mass. So the mass of carbon in our sample is 85.6, and the molar mass of carbon, which we just get off the periodic table, is 12.01 grams per mole. So when we do the math, we get 7.13 moles of carbon in our sample. Same thing with hydrogen. We have 14.4 grams divided by 1.01 grams per mole, giving us 14.3 moles of hydrogen in our sample. Next we just need to find the ratio between them. So if we have 7.13, 14.3, just divide by the lowest number that we have, in this case 7.13, giving us 1 carbon to 2 hydrogens. So therefore the empirical formula must be CH2. That doesn't really tell us much. Empirical formula was developed because, back in the day, this was the only information chemists could get from a material. But now there's a machine called a mass spectrometer, which actually tells us the molar mass of the compound that we're looking at. Using the molar mass, we can get the molecular formula. So, I have an example here. It says the compound above, the one that we just calculated its empirical formula to be CH2, the compound above has a molar mass of 28.06 grams per mole. We need to determine the molecular formula. So, we know the molar mass of this is 19.03, but this isn't the actual molar mass of the compound. So, if we have 28.06 grams per mole as the molar mass of the actual compound, divided by the molar mass of the empirical formula, we get 2, exactly 2, which must mean that this multiplied by 2 will give us the molecular formula. So, the molecular formula of the compound is just C2H4, which we got by multiplying the number of carbons and the number of hydrogens by this constant.